We've talked about weathering and the making of gross. Weathering also makes bauxite, makes hematite, iron ore. All right. Sedimentary layers. Here we are in the Canadian Rockies looking at Cambrian aged sedimentary rocks once formed on the ocean floor. These all formed today. Here's modern ripple marks. So calcite, dolomite, quartz, gypsum, halite, placer minerals like gold, all formed in sedimentary systems. All right? And I'll show you some real prospecting for sedimentary placer gold just a little bit. So here's hydrothermal at a mid-ocean ridge. Look at the quartz crystals, amethyst, gold, and silver. This is an underwater hot spring. It's called a smoker because it looks like smoke. All right? But that's not smoke. Those are minerals precipitating out of the hot water as it hits the cold water. Concentrating. You see the yellow? There it is. That's how most of the world's gold is created offshore. This is a real one on the East Pacific Rise. So these are called, whoa, bad, really bad. Fucked up. Oh, sorry. Pause. Where did that go? Oh my God, that's never happened before. All right, we'll find it. Here we are. Let's hope it's still there. There it is. Wow, what did I do? One of the criticisms that I got, that I go too fast. And that's good to know and believable, because I'm so interested in having you learn. I get wrapped up and excited about it, and then I start going faster. Is that right? And faster, and faster. And one of you said, look, you always finish class a bit early. Use the rest of the class time and slow down. I thought, what a good idea. I don't know if all of you married would agree with that. So, what a good idea. No? What, you mean you want to be out of class early? Or you want me to go all the way to 12:20? But it's allotted. I can go slower that way. I just don't know. You so confused me. See, it's equal. All right. There we go. Excellent. Metamorphic rocks. Here with a person for scale, standing next to a road cut. Look at all those metamorphic rocks. Get up close. Look at the garnet. Okay, beautiful garnet. It's also very hard. It can be used as an abrasive. We make sandpaper out of it. Minerals that are stretched by pressure and temperature are called metamorphic rocks. Only three kinds of rocks: sedimentary, igneous, and metamorphic. Okay, so there they are. Some are useful that are not metals, like quartz. Calcite. What do we use calcite for? Calcium carbonate, limestone, marble. We use it to make jumping up and down. This floor, under the rug, is the sidewalk outside this building is concrete. All right? Concrete is made from calcite. That's how we make it. We use the rocks that calcite is made out of, like limestone or marble, and you make concrete. The early Greeks discovered how to make concrete. All you do is heat the limestone, drive off part of the carbon dioxide, so you're left with just calcium oxide. Not a mineral, but they made it. And that's what cement is. Then, they learn how to do this. Then, they take that cement, calcium oxide, they burn off the carbon, so it went from calcium carbonate to calcium oxide. Then you add water to it, and that stuff gets hot, exothermic reaction, and it absorbs carbon from the atmosphere, and it goes back to calcium carbonate, concrete. Then you add sand and gravel to it to give it strength, and you've got real concrete. Okay? So the early Greeks learned how to do this, all from calcite. Fluorite for your toothpaste. We talked about the uses of quartz. Talked about garnet. Its uses in abrasive. Oh, lovely diamond. Diamond comes from the Earth's mantle. All right, and it's brought up by igneous processes. Parts of the Earth's mantle are glittering with diamonds. That's where it's found. All right, it comes up through volcanoes. All right, special ones called kimberlites. Ruby and sapphire. Ruby when you're red. Oh, ruby, sapphire, you're lovely and blue. Gemstones as well as abrasives. So all of these have their different uses. Mica for its insulating properties. Serpentine asbestos also used in insulation, although it's dangerous for our lungs, and so we do that. It is a carcinogen. We find other ways. Gypsum I've talked about. Lovely gypsum, making for sheetrock and plaster. Here it is. Formed by the evaporation. It is the mineral calcium sulfate plus some water. That's how it's formed. We need a lot of it, all right, because we're still building. Oh, there's gypsum and the salts, all formed by evaporation. And this over spring break, as I told you, I took a couple of you. There she is. There she is. On a spring field trip. There they are. Taken with my iPhone, so it's not so great picture, but they're standing on salt. Katarina and Emily, 13 students and an old man called me, standing on salt. That's a salt flat in California, Mojave Desert. All right, salt. We need a lot of salt in this world, not just for salt, not just for cooking, but also for the alkali metals. The sodium and the lithium and the boron are all formed by evaporation. Halite, what a mineral. Yeah, Roman soldiers used to be paid with salt. So that's where the phrase "not worth her salt" comes from. All right. Feldspars. We use them to make ceramics, plates, your mother's china. Add a little clay to it. We've talked about quartz, smoky quartz, lovely pink quartz, ruby quartz. There's an arrowhead, all made out of quartz. Also, petrified wood and dinosaur bones are all made out of quartz. And here are their uses. Abrasives. We can make cement out of it. We have to add sand to cement to make concrete, so that's quartz. We can use it to make optics, cameras, light bulbs, pressure devices. You can make a clock out of it. That's your crystal in your clock, and I've said that. And here, with a hammer banging away, is a big quartz vein. So when I find a vein of quartz out in the field, I stop. Because that quartz is hydrothermal, and most ores of the world are hydrothermal, hot water. Get out your rock hammer, and I call it geology lotto. And I beat on that quartz, and I break it open, see inside, to find some gold, so I can pay tuition for my students to go to school. Look at that. Metal ores, malachite and azurite for copper, magnetite for iron. Here's gold and real silver. Don't drink a hot spring. You climb in there, enjoy that warmth, but don't drink it. Maybe you shouldn't smell it. I wish to introduce you to my wife. That's Professor Jean Morrison, just a few years ago. And this is a 55-pound nugget of gold smuggled out of Australia. The only thing is we didn't know it was smuggled. And she assayed it. Turned out to be 92% gold, 7% silver, 1% copper. There it is. And I went to pick that thing up. Now, I can pick up 55 pounds, but gold is so concentrated. All right? I went to pick it up, and I teetered off to the side. And the guy that brought it in, smuggler, hey, don't drop that. He later got arrested. But Australia won it back. Bye, Gene. There you go. So metal ores, things like hematite can be gray and shiny or red. Hematite, here's a sandstone along the beach. Iron ore, don't you see? Magnetite. Magnetite because it's magnetic. All right? There it is. Pull the compass off. So all these different properties. Galena. Lead ore, always hydrothermal. Yeah, you can make a radio out of that too, using a Quaker Oats box. We used to do that because it's got the ability of being a semiconductor. Remarkable. Natural semiconductor like other minerals. Make a radio, because some minerals can detect radio waves. They suddenly transform that radio wave into sound. So minerals are amazing. You never knew you were going to have to sit through an hour and 20 minutes, or maybe just an hour, listening to rocks and minerals. And some guy shouting at you. Oh, wow, look at that gold mine. That's a pyrite mine. Beautiful crystals, pyrite. It's used as a sulfur ore, used as a very poor iron ore, but sometimes it's got gold in it. All right, so it's got possible uses. There's bauxite formula, aluminum hydroxide, not pure aluminum, but it's almost pure. Just drive off the water, just eat it, baby. It's called smelting. And that smelting is a dirty job. So here is a real bauxite ore ship, all right, digging it out of the ground. Here's the bauxite mine, digging it out of the ground, taking it to the smelter. That's dirty stuff. Using coal to burn it, drive it off the hydroxide, leaving pure liquid aluminum that you then cast into ingots. So the smokers are amazing. Hydrothermal, and we can have hydrothermal veins on land, but a lot of them are underwater. Hot springs, here they are. Some are black, some are white, depending on what their chemistry is. Okay, you do not need to know the difference between a black and white smoker, but there are smokers down there, and a lot of the world's hydrothermal veins are formed in that environment. Now, the whole thing is that life is unfair. The whole world needs these commodities. But the distribution of ores, just like coal and oil and gas, is very uneven. Aluminum. We love our beer cans and our sodas. All right? We hope you recycle them now. But the United States has only got 0.2% of the world's aluminum. So we got to import a lot. All right, where do we get it from? Well, Australia, down under, Guinea, Brazil, they are the big holders of the world's aluminum. Go for copper, it's all about Chile. All right, and lithium. Chromium, it's all about South Africa. Also the same for gold. Okay? So we really have to import almost everything except perhaps iron and salt. So the distribution of ores. The mining. You can go out on federal and state lands. If you find ore, you can claim it. And this started out with the Mining Act of 1872. You file a claim, and it's yours. All right? And you can then walk away from the disturbed ground and leave it quite a mess. That seems to be okay as well. Different kinds of mines. Some are deep, but we've gone more and more today to excavation, mountaintop mining, taking down the whole thing, processing the ore. Sometimes we use gravity. A lot of the times we leach it, dissolve it out with mercury, or worse yet, cyanide, used in the Holocaust. All right? Potassium or sodium cyanide, bad stuff. Sulfuric acid can also be used. We talked about using magnets, and also processing by burning it, smelting, using the heat of coal, a fossil fuel, which puts out carbon dioxide, the greenhouse gas. So it's not pretty. The impact of mining, it really is horrible. A single mine in Papua New Guinea generates 200,000 tons of waste per day. Every day. Every day. Okay? All right? To get production worldwide, we need a lot of steel. So last year, 84 million tons of steel was mined, 24 million new tons of aluminum. Straight out of raw rocks, 14 million tons of copper, and on a much smaller amount, 2,500 tons of new gold. All right? Worth $21 billion. So it's all happening today. It's all happening today, leaving quite a bit of waste. 1 ton of copper leads to 110 tons of waste rock and 200 tons of overburden to get it out. It's worse for gold. 1 ton of gold leads to 300,000 tons of waste rock. So it's a dirty process. Am I saying walk away from these mines? Am I saying let's no longer go to the store? Never again buy a car or a watch? Wow, maybe not. But that's the buy side. That's the part you don't see. It is a dirty job. 14,000 mine workers are killed by accident every year. That's crazy. There it is. Okay, worldwide. And in many parts of the world, third world nations, there aren't good laws to protect them. You see, not good laws. So it's a very And there's a so-called resource curse. This is real. All right, you're going to go into politics? Turns out the 95 developing countries with the highest natural resources continue to have the highest rates of poverty. Why? Who can explain why? This is the case for Guinea, Niger, Zambia, Jamaica, Chile, Peru, and the Congo. They all have huge amounts of resources. Nigeria, huge amounts of resources. And yet most of their populations remain illiterate. They don't live long. Why? Why isn't the wealth being distributed? Starts with the letter C. Corruption. Corruption. You know, it's just us, folks. We're all the same. We're just humans. All right? Why can't we do this? Wow. Is it going to take a gun? So, there are alternatives, and you know about recycling. Recycling only takes 5% as much energy to make aluminum from scrap as it does to make ore. But we have laws that are favorable to the mining industry, so they're protected. All right? I hope you will march out of these doors of Earth Science 105, march down the street, go in and get elected, be some great leader of the world, and save the world. We need good laws. It starts right here, though, with education. All right? And the other R's are even better. Reuse and reduce. Much better than recycle. So the impacts of mining, we have open pits, ground collapse, poisons such as cyanide and mercury, air pollution. One smelter in British Columbia released so much local acid rain that all trees within 12 miles were killed. All right? Now we have some laws in this country, but not everywhere, that the land must be returned to a usable state. But how is that possible after the mountaintop is gone? Yeah, so there's some issues here. It's what it looks like. You already know about acid mine leakage, and when you dig in and expose sulfide minerals, they'll start to rot. All right? And the iron will, out of the iron sulfides, the iron will become hematite, red in color, and that is sulfuric acid, okay, draining into the environment. But let's go look at this environment that makes these minerals. I want to show you a smoker. Here they are. Look at the yellow color, sulfur and gold, all right? So here are the smokers. This is a white smoker. These chimneys are no longer active. As the hydrothermal fluids come out, they precipitate, making a chimney. And so it's a chimney, all right? So they're growing new chimneys right now. These have been turned off. There they are. Here are black smokers in this hostile environment, 5,000 feet under sea level. The temperatures are so cold, it's near freezing, no sunlight, and yet in this sulfur-rich environment, worms. Worms thriving. Look at life. Life loving these hot waters. Get in the hot tub, babe. Look at that. With the spinning earth. Mid-ocean ridges, making pure quartz, making sulfur-rich iron deposits. You're going to do something again, aren't you? Oh, very good. California's gold transformed American history. When it was discovered in 1848, it caused the 49er rush, and peoples from Boston and anywhere else on the East Coast began to travel to the West. Some went by boat, and was that hazardous because there's no Panama Canal. They had to go all the way around the Straits of South America. Hostile seas if they made it. And others went by land. And most people had a covered wagon, but they walked because the covered wagon was for babies and pregnant moms and grandmothers and the rest of everybody else, including the dogs and cats. They all walked. But it transformed American history, and it was a family affair. Women, roll of women in the gold rush, they were there, out there with them in their full dresses, digging for gold, using water. Here we see gold pans. Here is a sluice box where they take shovels and pour the gravel in. And so we look at all the gold mines. Look at all the gold mines. This is California's gold country. Everybody coming in. But to get that gold later, they discovered to use cinnabar, as I described. And cinnabar, the red dots, cinnabar, and out here, those are the mercury mines, okay? Riogar, cinnabar, all out there to leach out the gold. And woman, was that poisoning the environment? But it's how it's done. Here is cinnabar. It's simply mercury sulfide. So what you do is you heat it. You heat it. and you drive off the sulfur, and then you have pure mercury that can then use to dissolve the gold. And there it is, cinnabar. Streams are poisoned by it. All right, it's called quicksilver because it dissolves silver as well. And here is some stuff from the web about cinnabar. You can read that later, but this is what I want you to see. Warning, warning, warning! Cinnabar is extremely poisonous. Do not use for healing or magical purposes. Legend and lore. None noted. Poisonous. Magical properties. Not worth it. Poisonous. Healing. Do not effing use. Poisonous. No, cinnabar. Principal ore of mercury. Native mercury liquid is rare. Occurs with cinnabar. Okay, so there's beautiful crystal. Don't play with it. After this class today, I will wash my hands. They're dirty. With minerals. Look at that cinnabar. Oh, lovely. It comes from the Persian zinafra, dragon's blood. It used to be used as a carving material in China. Can you imagine that? People work. It's a beautiful mineral. But you don't know what's in there, all right? So it actually deteriorates your nervous system, impairs hearing, causes involuntary muscle movement, curls your skin, causes swelling, be difficult. Your body needs metals, but only a certain balance, all right? So there it is. And what happens is that once mercury gets into the environment, it first gets picked up by the insects, and then the fish eat the insects, and then we eat the fish. It moves right up the food chain, getting concentrated because we eat a lot of fish. Okay? And the fish eat a lot of insects, so it works right up the food chain. That's how it gets concentrated. But there it is, all mined and formed into liquid gold and then pressed into bricks. This all went down 1857 after they dug the Panama Canal. Shortly after 49, first boat went through and it sunk. Later they discovered it, got it back out. So all of these are different stories. Marshall found the gold in 48. Sutter wished he had. The fever spreads. Everybody heads there. They call them the 49ers. The journey, 4 months on a ship or 4 months on foot. Shortcuts that weren't. The Panama Canal wasn't there. People were paying things like $100 for a glass of water. Plenty of gold, but not enough food. Truth about women. Go explore it all. It's all there. Despair. The gold runs out. The miners keep trying. Collision of cultures. Everybody's coming in, and it always wasn't pretty. Humans are pretty bad to each other, aren't they? And so the collision of cultures is there. San Francisco was greatly changed in just 2 years. The wonder of gold. Wow, we love it. So I want to take you to gold country, but this one is not in California. It's in Mongolia. And I was there just 3 summers ago. And these are lovely fields with sheep and cattle. We drove for 3 days after landing in Ulaanbaatar, the capital. Drove across the entire country. Finally, where the last day we had no roads. And as we were there, this was one morning, I woke up and all these were out in front of my tent. Mongolia, they're very much tied to their animals. They all learn how to ride horses as kids and raise sheep. The land is a lot like our country was, and Europe was, even 100 years ago. But I saw this. We were driving by and I said, stop the cars. That's a gold mine. And here they are. These are all squatters. They're their tents and others. These are families that learned somebody found it, found the gold, all right, and they all came in. The mining companies are coming. The mining companies are coming, and they will lock this place up. But until they get there, the squatters have moved in. They're finding gold. Here are 2 moms putting it through a shaker. They don't have enough water to process gold that way. So they're putting it through a shaker, and that will catch the heavy gold in it. You'll see that go. The sedimentary layer is about 20 feet down that's got placer gold in it. Here they are. People coming up with buckets out of that kind of hole, dumping it on the ground, pouring it through these shakers. There we go. With kids watching, using a gasoline-powered generator to get the gold. All right? These families are poor. But look, they're going to be rich. They're going to be rich this day. Gold. Worth a lot of money. This is our couple. Who came with us. She's watching. We're all watching. I got my camera water. A little bit of water out of the bottle. Use the water now to concentrate to float off the lighter minerals into the heavy gold. Where is it? Where is it? You got his file there for the gold they've already found? It's there somewhere. Oh, that's our driver who got just in front. Oh, and that's our cook. Wait a minute.
Can you ever show it to me again?
There you go. That's my voice. Amazing. Oh, wait, you see the gold? Go ahead. Where is it? Right there somewhere. Go! Take a shot. Take a shot. There it is. Wait. Wait. Look carefully. There! You see it? There it is. Flake of gold, one at a time. Scoop it up. Put it in. Scoop it up. Do it all over again. And look at that. Wow. Fresh, new gold. Right out there. All right? Oh, that's how we do it. That's how we do it. And then we left the gold, and these kids, we're in two vehicles, that's our other vehicle, these kids on horses are chasing us for fun. All right? They're chasing us for fun. Here we go. Oh, now they're coming over our car. And I took their pictures as they rode away. They waved, goodbye, Yankee. There you go. So cyanide leaching, not always a good thing. You can actually buy your own leaching tank. Put it right there and have a hobby of making your gold. This is what you're all after, but don't breathe. All right? Healing properties of minerals. Quartz. Quartz in rituals is meant to treat for convulsions. That's what I needed. Diarrhea, dizziness, exposure to radiation, general pain, hemorrhaging. Smoky quartz. Oh boy, it fixes your kidney diseases. You're good for your menstrual cramps. Helps you with your fertility. Rose quartz. Oh, treat your cardiovascular health, your fertility again, must be something there. It'll smooth your headaches away, get rid of kidney disease, your migraines, and general sexual dysfunction. And with that, I say good night and have a wonderful rest of your day. I didn't quite make it to 12:20.